So 7.1.4 is to explain the relationship between sensors, the processor, and the output transducer. So a sensor is a device that detects and changes in the environment and responds to some output. A sensor converts physical conditions into a measurable analog signal. Advantages are that they're reliable and they're quite quick, but they have low accuracy depending on the size of the object they're measuring. Processor and output transducer. A processor is a machine that processes something, and an output transducer takes electrical signals and converts them into another form of energy. A lamp converts electricity into light, and a motor converts electricity into motion. The relationship between them is that the sensor measures a physical quantity within the environment, is processed and then given to the output transducer, and the output transducer converts this electrical signal and is converted into another form of energy. 7.1.5 describes the role of feedback in a control system. So feedback, either the output or some feedback is either the output or some part of the output in the input side is utilized and put back into it, and then there's no feedback. There's two types. There's positive and negative feedback. And I wasn't sure because I haven't seen anything in IB, but there are formulas on how these work, like very complex formulas on how these work. So I thought maybe I didn't put it in because it doesn't seem like, seems like way university level IB computer science. And then you have two types of feedback system: open loop and closed loop. So open loop doesn't monitor or measure the conditions of the output signal, so there's no feedback. But this is simple and easy to construct, but it has low accuracy and reliability. And a closed loop system uses feedback where a portion of the output signal is fed back into the input to reduce errors and produce stability. Here it's more stable and more accurate, but it's quite complex and costs more.